Today we will be working Student Handout 3, distributing a negative number. A negative sign indicates the opposite of the number. Follow along as we write the opposite of each. So 8 positive, opposite negative 8. Opposite of negative 5, positive. Opposite of positive x, negative x. So negative 3x, opposite would be positive. Opposite of a positive 1 will be a negative 1, and the opposite of 9 will give me a positive 9x. So today we're going to talk about distributing with a negative. When distributing a negative number, you are multiplying each term within the parentheses by the negative number outside the parentheses, just as you would if the number was positive. But this negative here results in finding the opposite of each term within the parentheses. For example, the negative with the 3 is going to make the positive 2 become its opposite, and the positive 4 become its opposite. So as we distribute with that negative 3 multiplied by that positive 2, and distribute the negative 3 multiplying by the positive 4, then our result for our terms inside the parentheses will be the opposite of what they originally were. 2 positive becomes negative 6, and the positive 4x becomes a negative 12x. So basically, when we're thinking about multiplying with negatives, we still think negative times a negative is a positive, because same sign positive. And we also can think that a positive times a negative is a negative, different signs negative. But what we are specifically looking at today is that when you do multiply by a negative, then what you started with becomes its opposite. Negative multiplied by a negative is a positive. So this negative took the opposite and gave us a positive. A negative multiplied by this, or this positive, let's start with that. This positive multiplied by that negative will become its opposite. And so we use that because, as we've always said, it's always good to know the answer to your problem or your solution, and then know how to prove that. So our final answer, before we move on, because that right there is bothering me, 2 signs need to be rewritten with a single operation, because we know add a negative, subtract a positive. So this would be my final 2-term solution. Last step, let's turn that around. So the term with the variables first. Now notice this term is a negative term, so I'm going to take that negative, 12x, put it first, and this negative 6, and we'll put it second, and now we are done. So basically nothing's going to change for this lesson as far as our process. More of a focal point on the negative. So what we're wanting to note is, before we multiply, well, look, because this is a negative, then I'm thinking my 2 terms inside, each will become their opposite. That positive will become a negative, and that positive will also become a negative. It's going to work every time. See my negative 2? This statement is stating that when I multiply or distribute by the negative, the add-ins inside the parentheses become their opposites. So that negative first term will be positive, and that second term, which is a positive, will become a negative. And let's just prove a couple. We're looking at the first one. The process, again, is the same. We're going to multiply each add-in by -2. So, as we do, we can notice that the first term, which was originally positive, will become a negative, and the second term, which was originally positive, will become a negative because we're multiplying by a negative. Again, we're going to rewrite that in its most simplest form, and now we are done. I'll skip around, do a few, and then you will work the rest. I do see here this is a -5, so I'm thinking that my final expression is going to be two terms. The first term will be negative, the second term will be positive, because this negative takes the opposite of each term. And the math will work through itself. Following our same process, -2 times +g, and a -2 times a -5. As we simplify, we get a negative first term and a positive second term. And we're noting that before we start. Always nice to know what your final solution is going to resemble before you begin. We'll do one more together. Follow along, please. So before I began, I noticed the negative factor on the outside of the parentheses will create the opposite sign for each term on the inside of the parentheses. So that negative term becomes positive, and that positive becomes negative. You're going to complete the remaining problems. Fill in these two statements. Pause the video. Take a moment, check your answers. Pause the video. Flipping to the back, we have more practice. 2 are done for you. Pause the video, finish the other 4. Take a moment, pause the video, check your answers. Now we're going to work a few problems using models, number lines, and such, and simplifying expressions. So they're asking in number 15 to write an expression for the perimeter of a rectangle. Well, the perimeter, by definition, meaning distance around, can be written a couple of ways because it is a rectangle. One way would be to double. Okay, so we're going to write our perimeter expression by doubling the length and doubling the width. And if my length is written as an expression of x plus 6, then I'm just going to substitute the length for the expression x plus 6. Now I'm going to substitute the width with 3x minus 2. Because remember, that expression represents one length. And now I can find my simplified perimeter by first using the distributive property. And now we're going to multiply what we can. And now I have 4 terms. 1, 2, 3, 4. Two like constants. So we want to use that commutative property. Which now I'm running out of room, so I'm going to move down to the bottom of the page. And the commutative property allows me to focus on my factoring out the common factor to sum my coefficients. I can go ahead and add at this time, which will give me a positive 8. And which I left off the p equals, not completely necessary, but to be consistent. The perimeter is equal to the expression 8x plus 8. And then you're done. So you're just taking that knowledge and understanding of what you would do if you had all numbers and applying the same process, but using our properties to manipulate with our variables. So we'll look at number 16. This time they give me a length that I'm missing. They want me to find the distance between A and B. They only give me the distance of B to C on my model, but up in our directions they give me the total length. So if I know the total length and part of the length, I can find my missing length by subtracting. So we'll set up our problem as 10x minus 5, which is the whole length from A to C, 10x minus 5. Remember, that's one length. We can put parentheses or we don't have to. These parentheses are not absolutely necessary, but let's think for a moment, because if I'm going to subtract my given length, then I'm subtracting the expression 2x minus 7 as one number, as one length. So if you look at the expression I currently have written, or the subtraction that I currently have written, basically I'm only subtracting the first term. So in order to make sure that I want to subtract that total length given in an expression of 2 terms, I must put those parentheses. These parentheses are very important. And now I can see total length, take away length of B to C. And that's going to leave me with length of A to B. Before you begin, we want to see, and it's not always necessary to rewrite this, but what's coming up is important. So you see how I wrote addition of the opposite, because I got a positive 10x and I have a negative 5. That's a positive term and a negative term. I can see that here. Well, this subtraction, because I don't know really, if it's possible or impossible, has to be rewritten as addition of the opposite. Well, as I write my subtraction as addition, I must make sure that I take the opposite of each term inside the parentheses. So just like we do as if it was distributing with a negative. So I'm going to make that positive term will become a negative term. And this positive term will become a negative term. And now we're ready to simplify. We have 1, 2, 3, 4 terms, commutative property of addition will allow me to group my like terms so that I can factor my common factor and sum my coefficients. I can go ahead and add at this point, which would give me my negative 12 and I'm going to go ahead and go back down to the bottom. So I can get 8 from that addition problem, which my completed simplified two-term expression would look like 8x minus 12. Positive term, negative term. Completely simplified. We only have 2 problems left on this page, and we're going to look at one together, then you'll do the next. And the expression below represents the area of a rectangle. So what they're going to ask me to find then are the side lengths. So it's kind of like I'm undoing that distributive property. I'm going to go back to that factoring. So when you're looking for the simplest form, we usually go for the greatest common factor. But what I want you to notice, there's 3 blanks here because there's actually 3 options. And we're going to find all of them. So we want to what are the all possible. So I'm thinking factors of 6 and 12. One of them would be 2. If I factor 2 out of the 2 terms, then I'm left with 6x and 3. Another factor of 6 and 12 is 3, which would leave me with 4x and 2. And 6 is also a factor because it divides into 12 2 times, and it divides into 6 1 time. And those are the only factors that 6 and 12 have in common. So I can quick check, see 2 times 6, 2 times 3, 3 times 4, 3 times 2. 6 times 2, 6 times 1. On number 18, there are 4 blanks, but I'm going to ask you to draw 2 more because there are actually 6 possible side lengths. Pause the video, find all 6. Check your paper in the video when you are done.